Hello everyone, I'm Lara. In the previous video, we discussed how to choose the correct machining process to ensure that the product meets the precision requirements. In this video, we will continue to explore how to judge whether the quality of CNC machined parts meets the standards. Let's get started. To determine whether the machining quality of CNC special shape parts meet the standards, the course should focus on the 4 dimensions of dimensional accuracy meets design, surface quality meets usage, assembly fit is normal, and functional performance meets expectations. This should be achieved through multi-tool verification and scenario-based testing, taking into account the characteristics of special shape parts such as irregular shape, difficult to determine the benchmark, and high measurement complexity. Precision inspection is the foundation of products. Dimensional tolerances and positional tolerances will directly affect the function and performances of parts. Therefore, tools should be selected based on accuracy. If the accuracy range is plus or minus 0.01, you can choose measuring tools such as digital calipers, micrometers, and depth gauge. If the accuracy range is plus or minus 0.001, you can choose height gauges, level die indicators, digital micrometers, etc. If the product is complex and has multi-type sizes, a 3-dimensional coordinate measuring machine is required to automatically collect data and compare it with the drawings. For more information about CNC machining accuracy, there is a more detailed introduction in the previous video. If you are interested, you can watch this video. The surface quality directly affects sealing performances, wear resistance, and appearance effect of CNC parts. So surface roughness, surface defects, and surface integrity are important indicators for judging whether the surface quality is defect-free and meets the usage requirements. The smaller the value, the smoother the surface. The RA value is generally between 3.2 and 6.3, and there will be a distinct roughness on the surface with fine lines visible. When the RA value is generally between 0.8 and 1.6. It will be fine and smooth without obvious roughness, and almost no machining lines can be seen. If the RA value is generally between 0.2 and 0.4, the touch will be very smooth and have a certain mirror-like effect. This method can quickly determine the overall quality of a part. But it may not be accurate for minor defects or internal issues. Therefore, we still need to use the measuring instruments to inspect the products. In addition, CNC machining may cause phenomena such as wall hardening and micro cracks on the surface of parts, affecting fatigue strength. Therefore, we need to use a micro hardness tester to test the surface hardness. Most CNC parts are customized components, so passing individual tests does not mean they can be used normally. So we still need to verify their compatibility through physical assembly tests. We can use a 3-coordinate measuring machine for inspection. After assembling, measure the position deviation of the key features of the CNC parts from the overall machine reference to see if the inspection data meets the design tolerance on the drawing. Or use a feeler gauge to measure the key clearance to see if it's within the design range. In addition, the assembly tolerance table is a standardized data tool for regulating the dimensions and fit accuracy of a part during assembly. It has relevant data requirements for the assembling between parts and the range of dimensional deviations to ensure that the assembled components can meet functional requirements while avoiding excessive machining that leads to cost waste. We have compiled a simplified assembling tolerances quick reference table for you. If you need it, you can leave a comment or contact us previously. To ensure that the custom machine CNC parts can meet the final usage requirements, we need to determine whether the quality meets standards through functional tests simulating actual usage scenarios. For instance, for load-bearing components, brackets, and other spare parts, pressure tests should be conducted to observe whether there is any deformations or cracking, etc. For shaft products, torque tests should be carried out to determine if they meet the standards. Similarly, for CNC machining parts in different application scenarios, different performance tests will be adopted, such as sealing performance tests, motion performance tests, and so on. The above four directions of inspection are important indicators for judging whether the quality meets the standards. In addition, other related inspection will also be carried out according to the inspection standards and the specific needs of customers. For instance, physical property tests such as wear resistance, corrosion resistance, and high temperature resistance are conducted on products. And the material composition of parts is inspected to ensure that they meet the specific material standards and other tests. At Longwang, quality control and inspection run through every machining stage, from preparation, machining to finished product inspection. Every step is carried out under strict control. We must strictly control the quality of CNC parts machined so as to ensure that every customized part for customers meets the requirements and even exceeds expectations. So when customers recognize our products, it's also an endorsement of our quality and details. Quality control plays a crucial role in CNC machining. It not only helps us win the trust of our customers, but also enables us to stand out in the highly competitive market. This is Longwang and Lara. Welcome to like, subscribe, and keep following. See you in the next video. Bye!